So in reiterating the conversation about making sure that your best tires would be at the rear of the car, all right? So that would be an important thing. Want to lead into that with an idea that's called, that's referred to as a radial pull. So a radial pull is caused by a defect in the tire, and so in some respects, it can be, somebody buying used tires. So in a really simple way, this tire, the treads burn off over here and we've got more tread here. So the diameter on this side is different than the diameter on this side. And so this tire has a smaller diameter over here because it has less tread and a larger diameter here. So if you roll this tire down the road, it would be like rolling a cup. It wants to turn in a circle towards the smaller diameter. Now, you'll get that sometimes and that would make the car want to pull, right? That if we were, I'll face your direction, that if we were driving in this car and this was on the left side of the car, this car would want to pull left, right? And if it was on the right side of the car like this, it would want to pull right. And so that type of defect in the tire is referred to as a radial pull, and it's caused by the tire. Now, a radial pull like that you can get from people that buy used tires and throw them on their car, that they were on some car that had an alignment issue that wore out an edge, and then it causes this radial pull when they buy their used tire. But you can get a radial pull from a brand new constructed tire. And so just like I had mentioned, some of them being machine built and some of them are still built by hand. So, but either way, they're subject to error. Something can go wrong to where in the end, what causes this radial pull is that the diameter on this face of the tire on the shoulder on this side is a different diameter than that side. So that even on a brand new tire, when you first put it on the car, you can have a car that wants to pull to the right and pull to the left because of a defect in that tire. How you diagnose that is relatively simple. You cross the tires. So if I have a pull, to the right or a pull to the left, it can just be in the tires. So one of the things that we'll do is, even before we put on an alignment machine or anything like that, if it's something that just started and you check the suspension and it's all tight, one of the things that we would do at the shop is we could cross the tires. And if you cross the tire and all you did is move the tires and the car was pulling to the left and now it goes straight, then the pull was in the tires. And so that all it has to do is change. So if it changes somehow, that it was pulling to the right and you crossed the tires and now it goes straight, then it was that test that you did in crossing the tires proves that pull's in the tire. Now, if you want to diagnose it further, then you can cross two tires at a time, like your front axle, right? Cross those ones, right? And you'll know it's one of those two. The only system that I'm aware of that can truly diagnose down to a tire is Hunter has a machine on their balancing equipment. It's called a road force balancer, and they have a wheel that they'll place on the tire and measure the pressure and contact of that surface of the tire, and they can detect a defective tire and that would cause a radial pull during their wheel balancing procedure. You can also do what's called match mounting the tires in that, to where you balance all four tires and you tag them 1 through 4, and then that machine will log the data that it grabbed from each tire that balanced it, and then tell you where to place the tires. Put this one on the right front, put this one on the left front, put this one on the right rear, and this one on the left rear, and then they'll place the tires to cancel out a radial pull. But like I say, simple test, pulls right, you cross the tires. If now it pulls left or it drives straight or something changes, then you prove that pull was in the tires. Good enough. Can you do that with a directional tire? So I'm going to back up a few slides to a slide that we started with in the beginning to talk about a directional tire, because I'm realizing I forgot to say that. There are constructions of the tread that are directional, and what you're actually seeing up on the screen here would be a directional tire. And so you can see that the way the tread pattern is facing forward in this regard, so it's kind of a V that's going this way. So this would be designed for that V pattern, that tire to face forward, and it has to do with the way the tread is designed. And a simple example of that is that if you pet your dog and you pet it from the head to the tail, right, then all the hair lays down and smooths out. But if you pet it from its tail up to its head, you start to ruffle up its head. And so, or you start to ruffle up all of its hair on its back as you pet it. And so a directional tire is designed to be on a certain side of the car and to rotate in a certain direction because of the way the tread is laid down. Now, in that regard, this tire, because of where it is facing, right, would be designed to be on the left side of a car. If we're facing the direction that you are, this tire would loop out and it'd be designed for the left side of a car. Tires that have that are directional, they'll often say inside, outside, and then they'll have an arrow on them pointing towards the direction of rotation towards the front of the vehicle. Now, in what we were just talking about recently with crossing tires, all right? Then in crossing tires, could you do that test temporarily and cross the tires if you have directional tires? And the answer to that is yes, because it's a temporary test, and all I want to do is see if something changes. In the couple miles or whatever that you drive the car like that, you're not going to destroy the tire. However, if you left them like that on the wrong side of the car, then it's damaging to the tire in that regard. And so directional tires are relatively common. If you ever did cross them as a test, you want to move them back before you give them to the customer and give the car back to the customer. But a directional tire is designed to be on the right side of the car or the left side of the car. They often have an arrow pointing the direction of rotation, and the tread is biased that way. If they make a tire specifically for the left side of the car or the right side of the car, then you tend to have better tire wear characteristics, rolling resistance, it's a better performance for that tire to design one specifically for the right and the left. That being said, in your tire rotations for directional tires, you can only go front to back. You're not supposed to cross them, things like that. All right. So then we get to Uniform Tire Quality Grading System. I'm sure you guys have all heard of that. It's a system that was mandated by the government. And so the government required that a uniform tire quality grading system be developed and has to be put on every single tire. And so again, then that just makes the cost of the tire go up. So the irony is it's typical government that they make a manufacturer do something and there's zero follow through, right? So this, I forget how long this has been around, but it's been out for as long as I've been teaching. So it's been out for longer than 10 years. This system here is designed to help customers make better decisions on how to purchase a quality set of tires. And yet, for all the years that I've been teaching and all the classes that I've asked, well, have you ever heard of this? Right? Nobody's ever heard of it. The only people that have ever heard of it is people that are in the tire industry. And so I'm going to educate the world one class at a time, right? Or educate the public one classroom at a time. And so there's three areas of this: tread wear, traction, and temperature. And so we'll describe each one of these and how you would use this in a tire purchase to your benefit. So in this case, if we look at it, tread wear is rated at 300, traction A, and temperature A. So the way that this system is intended to be used is that, say you bought a set of tires for your car and they were 300 rated like that. And so if you know when you bought them and how many miles you got out of them, say that you got 30,000 miles out of those tires. So the system here is that if you bought another 300 series tire, regardless of how you take care of your tires, do you rotate them like you're supposed to or whatever, you got 30,000 miles out of them. If you bought another 300 series tire, you should expect to be able to get 30,000 miles out of those. Then if you upgraded to a 600 series tire, treadwear series then to 600, then you should be able to get twice the mileage out of it, 60,000 miles, however you take care of your tires. The kicker to that is to be able to use this system, you have to know how many miles you got out of the first set of tires, right? And so if you do know that, then this becomes a usable spec for you. That's kind of turned into what you see now for some manufacturers is when you look up a tire online or things like that, they'll kind of specify this is rated for 40,000 miles or it's rated for 60,000 miles or things like that. So it's kind of developed into that for manufacturers. They'll advertise the mileage rating that you should expect to get out of a certain tire. Now, traction. Traction is a ABC rating, A obviously being the best. And I think on this one they even have a double A rating, so 2 A's is better than 1. But in the system for traction, it is wet weather traction. So wet weather traction is its ability to clear water, and ice and snow and have good handling characteristics in wet weather or icy conditions. Now, in Bakersfield, do you think that you need a really high rating for traction? Not really, right? We're basically a desert, so that's not a real big deal. Now, temperature is an ABC rating there as well, A being the best. Then temperature is hot weather or hot temperature rating. So it would be beneficial for us in Bakersfield to have an A rating for temperature. So that's what that's all about, the UTQGS, Uniform Tire Quality Grading System. All right. So getting to a DOT code on every single tire that's out there, they will have a DOT code on there that gives information about where the tire was made, when it was made, and other specs about this tire. And it'll be a number that'll have multiple digits down the side. This is a number off of one of the tires that I have in the classroom. That few things that I think is important. Although it does give a lot of information, there's two pieces of useful information out of this that I think is good. One of them is a Y1 right here. The first digits there, Y1, will tell us where that tire was built. Now, this is the way that I think that is useful to know where the tire is built. Now, in Bakersfield, kind of a good old boy type of place, and where I grew up to, Reedley, Fresno area, Central Valley in general is kind of that place. You think you might ever have a customer that would come in your shop that wants a tire that's made in America? America, right? Of course. There's people that are out there. My neighbor, in the house that my wife and I had in Selma, was that kind of person that would run through all the clothing racks all over town trying to find shirts or pants or things that were made in the USA. And he was just patriotic that way. He was a military vet. That's how he felt about it, right? And they're, like it or not, whether you're that way or not, I'm not that way. I kind of buy things based on how much it costs and what I need, right? But how it looks or things like that. But my neighbor was one of those people who wanted to buy things made in the USA, and the reason why I bring this up is that if you know that on the tire the DOT code will tell you where it's made, then you can accommodate people like that are staunch about that are very patriotic, or for whatever their reasons are, they want to support this country and the people that work here. Can't fault them for that, right? And if they want to buy a tire that's made in America, there's a way we can find out which tires we have were actually made here. This Y1 is a tire that would obviously found its way to Bakersfield, but it was made in Brazil. A Goodyear tire, made in Brazil. And so that would not fit the bill for some of your made in America people. The next part on that is the date code. The last four of this is a date code. And so on here, this date code represents the weeks and the year. So the week in the year. So how many weeks are in a year? Don't say 12. 52. 52 weeks in the year. And so that would mean that this tire here was built in the 12th week of 2004. Pretty old tire. And so in that's somewhere then around March, into March to April, right? 12th week. Or March. Yeah, March to, that would be March, my bad. Typically about 4 weeks in a month, so that'd be March, somewhere in there. But cares for what? One of the things that I want to make sure that you understand is that this is beneficial to us because sometimes we'll inspect a tire and it happens a lot to especially older people that they get a tire and we look at it and there's nothing wrong with the tread. It has great tread, but the sidewall of the tire is split and cracked and it's deteriorated there. And so we would recommend that they replace their tires because of the condition and the aging of the tires and the weathering of those tires, that they're getting to a place where they're considered to be unsafe or unreliable at the very least, that they're likely to fail. One of the things you'll figure out with people is that when you go in, and especially when the tread is in good shape like that, you'll figure out real quick, tires aren't cheap, and so you go start talking to them about putting 4 tires on their car, and you'll find out real quick that their wallet is connected to their heart. That you'll give them that price, and they'll be like, oh man, really? Really? I need that expensive? I need to do that? I just bought those tires. I don't need tires, I just bought them. Right? And you'll find that kind of reaction from people, and you can kind of put them over the hump by letting them know, like, well, there's a date code on there, right? You might feel like you just bought them, but these tires you bought back, in 2008, they're 12 years old, or whatever, if hopefully not 2004, right? So, but that's one of the ways that we can gauge that. I've heard of people using it different ways, that when they go and buy a used car, right, off of a lot that's supposed to be, low miles and new, that they'll look at the tires and they'll go, oh wow, the date codes don't match on those tires, right? You hear stories like that, and they're like, did this tire get wrecked, or things like that. So there's a variety of ways that you can use that to your advantage if you know it's there. Spare tires, I mentioned, there'll be that T on our P-metric description. They'll have a T there. They're space saver spares. They'll be limited in that regard, that they don't want you to drive more than 50 miles per hour on them, or more than 500 miles. And like I say, when we first moved over here in the apartment complex that my wife and I were in, I swear that there was people that was trying to get matching, donut spares on their car to drive them around like that. So we get to wheels. So this is one of the areas I'm not really anal about this, but if you talk to older techs in the industry, it's common to refer to this guy. In our day and age, people will call that a rim, right? And so if you look at what's on here, the rim is this area really where the bead kind of sits, all right? That's the rim of the tire. It's a part of the wheel. The whole thing's the wheel. And so a lot of people will say, oh, I got rims on my car or whatever. Okay, so I'm not anal about that, I already said. But some techs in the industry you're going to burn their ears if you call the wheel the rim, all right? Because the rim is a part of the wheel, right? It's not the whole thing. And so they get bent about that. So know who you're talking to. If you're talking to older techs in the industry, you probably want to call it by its proper name, the wheel, all right? If you're hanging with your friends or whatever, your homies, and they call it rims, then you can call it rims, right? It's the same thing for me. The one that burns my ears is I hear some of my students call the distributor the dizzy. Yeah, the dizzy's bad on them. I'm like, what? So that's the one for me that is common kind of slang, I guess, nowadays among the little Ricky racers in the public. So couple of things about wheels. Super common to modify wheels and buy aftermarket wheels for looks or other reasons. Modifying your tires, and oftentimes when they get a different set of wheels, they'll want a low profile set of tires to go with it. So a couple of things about that. If I change the wheel to a bigger wheel, any modification that you do to your car is going to cause a higher cost in repairs, or a higher cost to maintain the car. A stock car will last you longer, you spend less money on it. You go and modify your car, you're going to increase the wear and tear on that vehicle, and through the life of that car, you're going to end up costing yourself more money. The wheel in this regard is something that when you change it out from like a 15 like this to a 20, you're increasing the weight for one, all right? So the weight of this wheel, a 20-inch wheel, is going to be a lot heavier than that 15-inch wheel or 16-inch wheel that you had from the factory. Now, understanding then that the suspension components and steering components were not designed for that bigger, heavier wheel, and so that's going to produce a lot more wear and tear on that vehicle from those trying to control that bigger, heavier wheel and tire, so it'll wear out more steering and suspension components. The other aspect to that is a lot of times when people change their wheels, then they will change the offset, all right, which then affects the way that tire contacts the ground. Sometimes I've seen people go and change the offset, and one of the things that can happen is that where it mounts up to the hub, they go and push it so far back in that if I move this surface back further in this way, right, further out this way, then more of this wheel protrudes into the fender well, and then you start having stuff hitting the fender well, suspension components and things like that didn't used to hit before, and people don't always account for that. But the other part of that can happen from modifying your vehicles in that regard is that a lot of times when they're changing to a different wheel, then they need a different size tire to support that. So in that regard, then we'll just pretend that the tires that we have here would be low profile tires, and then when I change from a smaller one to a bigger one, then it happened this way. all right? That we'll imagine that these were low profile tires with a bigger wheel on the inside. Now, you can see right now from that view that the circumference of this tire is different than the circumference of this one, right? And so one rotation of this tire would cover more ground in one rotation than this one would, right? And so because it's a bigger tire and its circumference, or the distance around this tire, is greater than the distance around this one, all right? And that's obvious just simply from the height of this tire. That if I were to roll this one in a full circle and this one in a full circle, that this one would get ahead, this one would get ahead of this one, all right? So a couple of things that will throw off. The speedometer, all right, is calibrated on that car to the stock factory size tire that's on the safety label or tire placard on the driver's door jamb. So this one be covering more ground in a rotation than the factory stock tire that would be on there means that with that bigger wheel and tire, you're going faster than what the odometer reports. You're also going a greater distance than what the odometer reports. And so the odometer is not accurate the longer that these have been on there, right? There are more miles on the car than what the odometer reports, all right? And then also driving on the freeway or things like that, you are going faster than what your speedometer is saying. So you might find yourself getting tickets. I've had customers come in that they're modified and lifted their trucks or things like that. And they're like, man, I got a ticket that I was going, 60 miles an hour in a 50 mile per hour zone. And like my speedometer said I was only going 50. And I said, well, with a modified vehicle like that, you're going to be going faster than what your speedometer is reporting. And so, and that would give them that understanding. One of the things that you can do to correct that is some of the manufacturers will allow me to go in and reprogram in the instrument cluster, the body control module, or transmission control module, wherever they hide that information. But I can go in and put a different tire size. And what I will try to do is, of the tire size that they have available, GM has a pretty small list, but Ford had a pretty long list on their factory scan tool that we had at the shop, where I could go in and tell that module that it had a different size tire to try to make the speedometer more accurate or the odometer more accurate. And so depending on the manufacturer, you may be limited on what tire sizes you can program into that car, but then that would help make the speedometer accurate. Back in the day, there was a gear that drove off of the back of the tranny, and people would switch gears to try to make it accurate if they changed tire size or things like that. But that's one of the options that we have nowadays, and in other cases, there's no fixing it. All right, your speedometer is going to be off, and the faster you go, the further off it's going to be. And so it's not just it's 5 miles per hour faster. It's kind of exponential the faster you go. But something to consider that way. And on top of that, you're gonna cause more wear and tear on your cars. Now, that's not going to stop a lot of you, and I also don't want you to be embarrassed if you have a heavily modified car and you want to bring it into the shop. I've worked on all kinds of different stuff. It doesn't bother me. I just want you to be, and I won't think bad of you, and nobody else is going to think bad if you have a lowered truck or a lifted truck and you bring it in, even if you lowered it wrong and you cut your springs. I've seen it all, so don't get embarrassed about that or any of that stuff. Still bring it into the shop and we'll work on it. I'm not going to say anything or give you a hard time at all. I just want to make sure that you understand that there's a cost to that. That's not just the cost of the modification that you're doing. It's a long-term cost of owning a vehicle that is modified, and there's a cost that comes along with that. So the tire placard is what we'll see on the driver's door jamb. Typically, most of the time they're there. Sometimes it'll be in the center console. If you got bucket seats in the front, it's got a center console. Sometimes they're in that console. Some of the manufacturers put this in the trunk. But most commonly it's on the driver's door jamb. What we find on there is information about the recommended pressure for the tires to make the tire pressure monitoring system happy and what that manufacturer recommends for tire pressures. And then also you have the proper tire size. And so on this one, you see they're recommending a 255/60R17 is the recommended tire. And so I can see what's recommended for that car. It'll also give specs, about the load rating, recommended load rating for the tire as well. So inflation pressure is important. We would know what pressure we're supposed to inflate the tires to from that tire placard. If you overinflate the tire, then you tend to burn the middle of it out. If you underinflate it, then it will ride on the edges out here on the shoulder of this tire down towards the sidewalls, all right, and you'll wear the edges of it out. If you have an alignment issue, then you get tires that look like this one, right, where it burns an edge out of the tire. And so that generally we would say is an alignment issue. We would not equate that to camber or toe or things like that unless you see the angle that it's sitting at on the car. But if I just see a tire like that, I can just say it has an alignment issue. I'm not sure without looking at the alignment numbers whether that car has an issue with toe or camber, but one of those two would cause it. So wear on one edge, alignment issue. Could be caused by worn steering or suspension components, or just being knocked out of alignment from hitting potholes or hitting something, car accident or things like that even. If you get wear down the middle, they're overinflating their tires, which probably means they're inflating it up to the pressure that they're seeing on the sidewall of the tire, which is a max pressure. So you shouldn't really air them up to that. If they're wearing on the edges, then they're running around with a low tire all the time, and they'll wear the both edges out. Some of you might ask, like, well, you know, generally, just as an example, when the max pressure says 44 for most of your passenger car tires, usually the spec on the tire placker will be like 35 psi. When you see a max pressure that is 50 psi, they'll usually be 37 or 38 psi. All right. My E-rated tires that are on my truck that I tow our trailer with and stuff like that, 1-ton trucks and things like that, you'll often see on your E-rated, they'll have an 80 psi max. When I'm towing, 80 psi in the rear over the axle, but when I'm not towing, I'll put those at 55. All right. So if you ever see cars that have green caps, all right, if you see cars that have green caps on them like that and like this, then what that means is that customer has paid extra money to have their tires inflated with nitrogen. Now, that costs extra money to inflate tires with nitrogen, so you get about 95% nitrogen in the tire. The reality is what's in our air right now is about 76% nitrogen, right? So if that's not good enough for you and you want 90% nitrogen, you got to pay extra money, and they'll charge $2-3 a tire usually to fill them with nitrogen instead of just regular air. But if you do that, it is actually not a bad thing. Whether it's worth the money or not is up to you to decide, and up to your customers if you offer that at the shop where you work. But in that regard, the nitrogen's a bigger molecule, and it's the biggest molecule of what's in our air. And so if you inflate your tires with nitrogen, then they tend to hold the pressure that they're supposed to have and stay inflated to the proper pressure for a longer period of time. And so that is better for fuel economy to stay at the proper inflation pressure. It's better for tread wear life and things like that. And so that's the benefit of filling a tire with nitrogen. So if your shop does not have a nitrogen filling station, then you probably don't want to just put your regular shop air in that customer's tire. If it's low, they'll take it back to whoever put the nitrogen in their tires and have them top it off. So a little bit about tire repair and service. Talked about tire rotation a little bit about how we do not cross the directional tires, but this is just a grid of a variety of different ways that you can rotate tires. The general rule of thumb that I would want you to write down, it's important and it's in your lab book, is that the general rule of thumb for tire rotations is that we cross the non-drive wheels. All right? So we've talked about that in our preventative maintenance lecture as well. But we generally do tire rotations every 6,000 miles. You cross the non-drive wheels. And so in this case, if this was a front-wheel drive vehicle, then our drive axle is here. Our non-drive wheels would be here. So we would cross our non-drive wheels to the front and bring our front tires straight back. I'm going to skip over this one. But if this was a rear-wheel drive vehicle, then our drive wheels are now in the rear. So our non-drive wheels are here. We cross our non-drive wheels to the back and bring our drive wheels straight forward. If you had directional tires, then you cannot cross them because there's right and left side tires, so you just rotate them front and back. If you had staggered tires, where you see a lot of on sports cars, where they've got wider tires in the back and skinnies in the front, then on a car like that, you can cross them as long as they're not directional. Then I can do my front side to side and my back side to side because they have wider tires in the back and skinnies in the front. This is a rotation, a couple of examples of how you can rotate your spare into your rotation. I generally never do this, although that's one way you can. If you're not sure if a tire's directional, it's never going to hurt to just go front and back and not cross. If you happen to buy, I've mentioned already, and if I haven't, I'll say it now. I generally give my students this advice. If you don't make luxury money, don't buy luxury cars, all right? A luxury car is a status symbol, so they're not trying to save you money on a car like that. They're trying, like in the case of BMW and Mercedes and Lexus and stuff like that, they're trying to just do the best, right? So in that regard, all the bells and whistles you can have, all of that's more expensive to fix if it breaks and stuff like that. But then also BMW, when they do their brakes, they're doing what is best for stopping, right? And so they tend to use a soft rotor material and then a harder pad material to where by the time the pads wear out, it wears the rotors out too. And so when you do a brake job on a BMW, or when we did it at the shop, it was about $500 per axle. All right. There are cars out there, and BMWs are one of them as well, Mercedes as well, that they come from the factory with what's called a run flat tire. A run flat tire is one that if you lost all the air pressure on it, that it has like a honeycomb on the inside that you could drive that tire with no air pressure in it. You could run it flat and still get home. All right. Those tires are super expensive. They're like $400 or $500 a piece. My sister-in-law is a beautician, and when she got into that industry, it's kind of an uppity industry, and a lot of them were driving luxury cars and stuff like that. So she bought a BMW, and then when she's got my little niece has a kid, and driving my little niece around in the car, and when it came time, we would do the work on that car, and I'd look it over, and it came time to buy tires. She couldn't afford the tires. They were $400 a piece for that car, so she needed $1,200 in tires. And here's the kicker: on a lot of these luxury cars, they're staggered, so they have wider tires in the back, all right, than they do in the front, and then they're directional on top of that. And so you cannot rotate the tires on those, even if you wanted to. They're directional and they're staggered, right? So I can't do this. And I can't do that because they're different sizes. So you don't get to rotate the tires. You just drive them until they wear out, and they're going to wear out faster if you can't rotate them. But that's not their concern, because you bought a luxury car. You bought it because they did that because that's what's best. They're rear-wheel drive, those cars are, and so it would be better for traction to have wider tires in the back. They're going to get better handling stability off of directional tires on that car, and so that's what they put on there. That just happens to mean you can't rotate them, all right? And so she didn't have the money to do it, and I told her, I said, hey, I will buy your tires, and you're going to sell this freaking car, and you're going to get a regular car, all right? And if you can afford a car like this later, then fine, right? But right now, you can't afford to own this car. Freaking get rid of it. And so I bought her tires. She got rid of the car, all right, and got a Honda CR-V. Reasonable car for her to get for the money that she was making. And so that's that. But something to consider in that regard. Does BMW make a fantastic car? Heck yes. That is one of my favorite cars to drive. They handle fantastic. They ride smooth, they handle great. Love driving those cars. If I were to buy a sports car, I would want an M3. They're a fantastic car, super fun to drive. But my rule of thumb, myself, is I don't have a reason to have a car like that. But if you don't make luxury money, then it's probably not a good idea for you to buy a luxury car. Tire pressure monitoring system we talked about. There's a couple different methods that they do this. They do a direct measurement that we mentioned where they're putting a sensor inside there. I didn't show you this one before, but pretty much everybody does a sensor like this in the valve stem, and one manufacturer does it like this. So there's one manufacturer that kind of likes to be different than everybody else, and so that would be Ford. Everybody else, Ford. So, I don't have a problem telling you that the way that these are installed, the in this regard, because the reason why I say that is because it's in your lab. But the way that this is installed is they would belt this. This is intended to be installed on the drop center. All right. And so this area of this wheel is called the drop center. It's the narrowest diameter there. And so where our valve stem is right here, if our valve stem is down here at 6 o'clock, this is intended to be directly opposite of the valve stem. And so where they put these sensors is some of them are in the valve stem, and then others, like Ford, all right, will put theirs directly opposite the valve stem. So when we do tire work, we'll break the bead here or here so that we're never actually hitting or running the risk of running a claw in there and smashing the sensor like what happened to this one, all right? And so that's how you dodge these sensors when you're doing tire work there. But those are direct methods where they're using a sensor to report. Other manufacturers will actually do this, where they use a wheel speed sensor to report. So how could they use a wheel speed sensor to report low tire pressure? If I had a wheel or a tire that didn't have as much air as the rest of them, would that create more friction and drag as it rolls down the road? Answer is yes. And so a low tire will have a tendency to spin slower than tires that are aired up to their proper pressure. So if it has a low inflation pressure, it would tend to spin slower or rotate at a slower speed than one that's rotated or that is inflated to its proper pressure. And so manufacturers that are kind of cheaping out on this mandate, they would do what's called an indirect method of measuring tire pressure by tracking the rotational speed of each tire. When they see one that's spinning slower than the rest, then they would know that that tire is running at a lower pressure than the others. This is just a picture of the sensors that would be located in the tire. They'd be reporting to a module, and like I mentioned, it's typically a radio that they report to because it already gets a wireless signal. Obviously, because these have batteries, they have a tendency to have batteries go dead, and then the systems quit working. You get a blinking tire pressure monitoring light. The replacement for these is a procedure that you just follow what's in Mitchell or ALLDATA, our service information on how to replace them, how you initialize them, how you get it synced to that computer, but it's just a procedure. One of the things I'll warn you about is there are way too many cars out there on the road and too many ways to do things that if you don't like to read, this is going to be a rough industry for you. So I'm kind of one of those. I don't like reading, but you have to read in this industry. You have to read because you're not going to know how to do it all. You're going to have to learn to read technical information and figure out how to walk to that car and perform that task. Indirect method, input from our wheel speed sensors on our ABS will give an indication of whether you have a low tire or not. So a little bit about tire replacement. Choose a tire that's going to match your original size. Conditions that require replacement is if you get tires that separate, you got bulges or blisters, ply separation, broken or cracked beads, fabric, cracks or cuts, wear indicators are showing just worn out, or you get punctures bigger than 1/4 of an inch, or any punctures in the sidewall or tears in the bead or things like that. In general, it's best to replace tires in pairs. Mount your new tires on the rear of the car like we talked about, and if you have a car that's all-wheel drive, then you get to do all 4 tires. Changing the tire and your wheel size, they have to be able to carry the weight of the vehicle, so make sure you're getting the right load rating. If you get one that's a different diameter, it can affect your speedometer and odometer like we talked about. On your all-wheel drive applications, you have to have tires that are all 4 the same size, so make sure you don't screw that part up. Most of the punctures that we have can be repaired. Make sure you're inflating your tires in the proper pressure. You can spray with soapy water to try to find any leaks. You'll get bubbles there. I'll usually, because I'm impatient, I usually spit on it, right? Or I'll spit right on the tire and see if I get a bubble that comes out. Watch out for your TPMS systems when you're mounting and dismountings. The sealants that you'll get in tires, I've had a good time with some of those. I've had some customers that are like, I had one guy that was like a aspiring do-it-yourselfer, and he would bring in some pretty screwed up stuff sometimes that he did to his car at the shop, and One of the things he did one time is he brought a car in because it was vibrating and shaking. Tires that are out of balance, they usually will shake at freeway speeds. All right, so if we have a tire that's out of balance, it's usually something that is causing a vibration or shaking up at freeway speeds. Well, what that poor guy had done is he took a whole bottle of Fix-A-Flat and he shot a whole bottle of Fix-A-Flat inside his tire. Unfortunately for him as well, he also had a TPMS system in there, so not only did we have to dismount the tire and clean all of his Fix-A-Flat out to make his vibration go away, fix the puncture that he had in his tire, which that was fixable, but he ruined his TPMS sensor in that tire as well. And the Fix-A-Flat didn't stop his leak either, so pretty fun. One of the things that I would recommend to you, we're going to get into a little bit of our tire repairs this way, but a lot of times you'll have wheel weights that are stuck around the outside. If we're just doing a flat repair on a car, it's a good idea. You're going to have to remove the wheel weights, but what I'll often do is I'll mark where the valve stem is on the rubber part of the tire, and then I'll go through and mark the wheel weights that I take off on the front side. And so that way, when I get done with my flat repair, putting my patch plug in, I can line my mark up back to the valve stem, and then I can put my wheel weights right back on the same location that they were, and it'll make it quick for balancing those tires. Another little trick is if you're putting 4 tires on, if you don't want to have to relearn the tire pressure monitoring system, then what I'll do is I'll write on the inside of the wheel right here, I'll write, right front, right rear, left rear, and after I get done mounting these tires, I'll put the wheel right back in the same location that it was so that I don't have to do the relearn procedure. You'll start to think smart in this because time is money to us, right? Every 6 minutes is $10 for a $100 labor rate. Different ways of patching we've already talked about. This would be the preferred method with a plug patch. I've already talked about torquing your wheels to specifications and following a torque pattern. This is one of the examples where we use our crisscross pattern. In balancing tires, some of the issues that we have, that this is one of the things you'll do out in the shop, is practicing mounting and dismounting. Now, I've already mentioned, typically you'll have customers that'll come in, they'll say, oh, well, my car shakes, right? So the next thing that I want to know is how fast they're going when it shakes. So partly so I can duplicate it when I go out on my road test, but also it gives me an idea of what's probably going on. So usually when we have a customer that says that it shakes, I'll usually present it to them this way. Does it shake like while you're driving around town, or does it shake when you're at freeway speeds? And if they say freeway speeds, then typically the number one cause of a car that has a vibration or shaking at freeway speeds is tires that are out of balance or wheels out of balance. And so when you think about that, the tire has the most opportunity to become out of balance in the contact that it is with the road. If you get, if they're a pretty crazy driver and they're skidding to stops, or their kid took their car and e-brake slide, and flat spotted it, and stuff like that. Sometimes the parents don't pick up on that stuff. But there's a couple different ways that tires come out of balance, and one is called static, the other is dynamic. Now, static is very simple, that we're out of balance really on end to end overall, right? That this side is heavier than that side, right? So then as that tire rotates around, every time that heavy side comes up to the top, then it's going to oppose gravity and want to lift the tire off the ground, right? And then every time it comes around to the bottom, it's going to want to plant it, right? So you have a tire that as it rolls, it may want to kind of bounce and roll across the road as that heavy spot comes and it starts opposing gravity as it's rotating. That would be a static imbalance, that if it's heavy here and light there, then when I balance it, I would add more weight here. A dynamic imbalance in that regard is a heavy spot side to side. So dynamic also means moving. And so in this regard, if I have a heavy spot side to side, then as that tire is moving, it tends to want to make it wobble. Right? That heavy spot pulls it this way and then pushes that way or whatever. And so it tends to make a tire want to wobble. So a static imbalance typically calls what we call wheel tramp, where it bounces up and down on the road this way. And then a dynamic imbalance tends to make a tire want to wobble side to side. When we do any of our tire balancing, when we go through and mount a new set of tires or balance a set of tires on a car, then we'll typically, then our tire machines will cancel out, and we'll add one location weights in a lot of cases to cancel out static and dynamic imbalances at the same time with computerized balancers that we have nowadays. So wheel tramp, right? That that heavy spot would plant and then lift it off of the ground when it comes there. And then if we have a dynamic imbalance this way, then it tends to want to make the tire wobble side to side. So we'll cover mounting, dismounting procedures for wheels and tires. And then when we get into lab, probably at some point too, we'll have somebody that has a puncture in their tire, and I'll get to demo a flat repair for that as well. But you'll practice mounting and dismounting, and practice on tires that have TPMS, so the proper way to do it without damaging them. Because if you don't dismount that tire correctly, then you can end up breaking a sensor, and then that's on you for not knowing how to do that job correctly. And so you don't want to do that, because those sensors are $60-$80 a piece. Walmart has been one of my good customers historically, that their tire techs over there broke a lot of stuff, and then we would do a lot of the repairs for our customers if they got their tires jacked up. So good enough.